Hello dear students, this is problem number 19 of chapter 4 of engineering mechanics TEDx 9th edition. Okay, in this problem this is a loaded truss in which we will determine the force in member AB, CG and DE of the loaded truss. Okay, this is the loaded truss at which we will find the force in member AB, CG and CG in this member and DE which is this member DE. Okay, first of all we have to draw a free body diagram and then I write all the show all the reaction forces in this diagram, but you don't have to do that. You have to, the first of all you have to draw this diagram and then you have to draw a free body diagram in which you have to show these reaction forces and you have to remove these supports. Okay, so this in this diagram, this in this truss it is loaded by L by 2, half load here and one load is here. This is the generalized problem. Okay, so one load at point C and one load 1L at point D and half L at this support which is at point E. L divided by 2, half. Okay, and the distance between A and B is D. The angle we have to find this angle alpha. So how you find this angle? We know that the tangent theta equal to opposite side, opposite is D, and adjacent side which is D. D divided by D which is equal to 1. So tangent inverse equal to 1 equal to tangent inverse D divided by T, it is cancelled. So tangent inverse into 1 equal to 45 degree. Okay, now there is more than two unknown forces at every joint. If you take this joint, or if you uh, choose to analyze this joint, if you choose to analyze this joint, this all joint have more than two unknown forces uh, by V, and we cannot find these forces because the forces in these members. And first of all what we have to do, we have to do we have to uh, isolate this whole truss and show the reaction force in the free body diagram and find these all reaction forces. Okay, so first of all we have to draw free body diagram and uh, the first equilibrium equation is summation of moment at point A equal to 0. Let's say anti-clockwise rotation is positive, clockwise rotation is positive and anti-clockwise rotation is negative. So you know that moment equal to RF, radius or distance into load into force. Okay, so first moment will be created by this L, the first moment created by this L which is L into D. So L into D, D for distance into L. So plus 2D, this is 1D and 2D, 2D into L. This also rotate clockwise and which is L, L 2D into L plus 3D into L which is this 1, 2, 3. This L is far from A point at 3D distance into L. Okay, so 3D into L plus 4D into L by 2. So this is 4, 1, 2, 3, 4D into L divided by 2. Okay, and this is also a force which is uh, exert at point A, which exert force at point A, but here is the distance 0, but we can say that L divided by 2 into 0 which is 0. Okay, so we can't find this load because it cannot create movement at point A. Okay, create rotation at point A. So the next force which create rotation is NE. This NE is at angle of 45 degree. Okay, so first of all we need to uh, vertical uh, we need to take a vertical component of this NE. We will take a vertical component. This it have two component. One is this is for example resultant force, and this is its horizontal component, and this is its vertical component. A horizontal component cannot uh, produce movement in this truss at point A, cannot rotate at point A. Okay, this vertical force of NE will be in this case useless. Okay, this is useless cause 45. Okay, but this uh, component of this force will be engaged to uh, rotate this truss in anti-clockwise rotation. Okay, NE sine 45. That's why I take this component of this force. So 4D 4D 1 2 3 4 4D at the distance of 4D from A to E, and the component of this force, component of this force, which is NE sine 45. NE sine alpha, alpha is 45 equal to 0. So if you calculate this all, it will become D plus 2D, 3D plus 3D, 3 plus 3 4D, 4D plus 2D. I cancel it. 2 1s are 2, 2 2s are 4, plus 2, 6 plus 2, 8D into L, negative minus 4D NE sine alpha, sine 45 equal to 0. So NE will be equal to 8DL divided by 4D sine 45. If you calculate this, the answer will come, NE will become equal to 2.8 2.828 L. Okay, so now the second equation of equilibrium is summation of all horizontal forces acting on this truss. Okay, so now horizontal force is, one force is this AX, and one force is the component of NE, which is this. Okay, this is a horizontal force, and this is also horizontal force. These two forces acting on this truss. So AX negative NE cos 45 equal to 0. This component is NE cos 45. So NE cos 45 equal to 0. So AX will equal to NE cos 45. So at the place of NE I put value 2.828 L. And so AX equal to 2.828 L multiplied by cos 45. So if you calculate, AX will equal to 2L. Okay. Now summation of all vertical forces acting on this truss, which is AY, L by 2, L, and L by 2, and one component of this force. This is also vertical force. Okay. So this is 3L into half, 3L plus half L, 3.5L plus half L, 4L. So you know that AY, which is this force, and negative NE sine 45, which is this component of this force, NE sine 45, and negative 4L equal to 0. Okay, AY will equal to NE sine 45 negative 4L. So AY will equal to, okay, AY will equal to 2.828 sine 45 plus 4L. So from this the answer will come AY equal to 2L. Okay, so we find it out all the reaction forces, and we find out NE, AY, and AX. All these reaction forces we have find that. Now there is two unknown forces and three known forces. AX also known to us, ay also known to us, and L divided by 2 is already known. Okay, that's why we have to take joint A. Now in joint A, I draw a free body diagram of joint A and show all the forces which acting on this joint. This angle I also show that this angle. So summation of all vertical forces acting on this joint. So no, I also assume that this all forces in members are in tension. These two forces are in member. This is the reaction force, this is the reaction force, and this is load. So these forces in member are, I assume that these are in tension. And summation of I take equilibrium equation, which is summation of all vertical force is equal to 0, because in this the one vertical force is unknown and the other vertical force is known, so we can easily find out the unknown force. So summation of all vertical force is equal to 0, which is L by 2 directed downward. That's why I put here negative sign, plus AY, which is AY, this this is also known to us, this is also known to us, and AH sine 45, this is not known, the component of this AH. Okay, so negative AH equal to L by 2 negative AY divided by sine 45. If I remove this sign, I will change all this sign. So AH will equal to negative L divided by 2 plus 2L sine 45. If you calculate this, AH will equal to 2.121 L. Okay, so no summation of all horizontal forces acting on this joint equal to 0. Horizontal force, one is this horizontal force, other is this horizontal force, and one is a component of this horizontal force. Okay, so AX, which is this force, plus AB, which is this force AB, plus AH cos 45 equal to 0. AB will equal to AH cos 45. At the place of AH, I will put here the value of AH. I put the value of AH, and AX, I will put the value of AX, which is 2L. So AB will equal to negative 3.5 L. So the negative sign means that my assumption was wrong. It is not in tension, it is in compression. So now I check joint E to find out the force in the required members. So this is my joint E, and this is a force acting on this joint. So I will take summation of all vertical forces equal to 0. Vertical force, one component of this force and one vertical component of this force, and this is also, there are three vertical forces. So L divided by 2 negative FE EF sine 45, which is component of this force, and NE sine 45, which is component of this NE, equal to 0. So EF equal to negative L divided by 2 plus NE sine 45 divided by sine 45. So if you calculate this, at the place of NE, I put its value 2.828 sine 45, 2.828 L sine 45 divided by sine 45. If you calculate this, EF will become 2.121 L, which is in tension. The positive sign means that it is in tension. My assumption was right. It is in tension. So summation of all horizontal forces acting on this joint, E joint, equal to 0. So this is force DE, negative DE, which is negative DE, negative EF cos 45, EF horizontal component of EF cos 45, negative NE cos 45, negative NE cos 45, okay, equal to 0. So DE will equal to negative EF cos 45, negative NE cos 45. So DE will equal to, at the place of EF, I put its value, EF value 2.121 L cos 45. I take it as it is, negative 2.828 cos 45. I take it as it is, cos 45. So DE will equal to 3 point, if you calculate this, D will equal to 3.5 L, which is the negative sign shows that it is in compression. Okay, now the last joint which I will take, and my other all the required forces in member will find it out. So I will take a joint C to find CG. Okay. So summation of F of I equal to 0, all vertical forces at point C equal to 0, at joint C equal to 0. So there is only two forces, which is negative L, negative CG. So negative L and negative CG. CG equal to negative L, which is the negative sign means that this is not in tension. It is, my assumption was wrong. It is in compression. So CG will equal to 1L. So this is the required answers which I find it out, which was asked in a question. AB 3.5L and DE 3.5L, and this are in compression. So CG is also in compression 1L. Okay. Thank you very much.